Today we're in lesson 1.2, which is on points, lines, and planes. Points, lines, and planes are the building blocks of geometry. They are our most basic things. We actually say we cannot even define them because they are so basic. We can describe them, and we will give some descriptions of them, but we say that they are so basic, they should just be understood as ideas, and we don't define them. What this means is, on your test, when there's a definition section, if I ask you to write the definition for point, line, or plane, you should say, there isn't one. It is undefined. These three terms we say are undefined. There's no way to put into words really, truly what they are, but we just kind of all understand what they are. Now, we are going to describe them so we're all on the same page, making sure we know really what they are. A point is the simplest figure in geometry. It has no size at all. Now when you draw it, it has size because you have to be able to see it. You can't draw something with no size at all. Your pencil lead has size. But truly in geometry, a point should have no size. When we name it with a capital letter. A line is a figure that is totally, fully made up of points. So we might not label all the points in it, but a line is completely full of points. It extends in two directions without ever ending. It goes on forever and ever in both directions. It has no thickness because it's made up of points which have no size. So again, when we draw it, it's going to have thickness because our pens and pencils are going to put down ink or lead and they have thickness. But truly in geometry, a line should have no thickness. There are two ways we can name a line. We can name it either with a single lowercase letter, so we could call this line L, or we can name it with 2 points that are on it. So we can pick any 2 points, so the two labeled on here, A and B, and then we put a symbol above it, which should look like a little line itself. On your worksheet, it broke up that symbol. It should be one continuous piece. I don't know why the font does that to it. But it should have a little symbol above there showing that the thing we're talking about is a line. A plane is a flat collection of points and lines. It's completely full of points and lines. It extends forever kind of in forward directions without ending. Now when we draw it, it has edges because otherwise we wouldn't see it if it didn't have edges. But truly it has no edges. It has no thickness. And we name it with a capital letter just like we do a point. So these things kind of build up from each other. We start with a point, which is the tiniest thing possible. When we connect a lot of those, it makes up a line. Then as we extend from there, we get a plane, which is like a piece of paper. Okay? A piece of paper has some thickness, not a lot, but there is a little bit of thickness to it. But that's kind of the idea of a plane. It's like a piece of paper that goes on forever. Questions on those terms? Now remember, these are just descriptions, not definitions. So on the test, if I ask you to define one of these terms, you should say, I can't. Okay? They are not defined. These are descriptions. These now are definitions. Space is the set of all points. It's everything. So we have this progression from the tiniest thing of a point, stretching that out, connecting a lot of them together, we get a line. Putting a lot of those together, we get a plane. And then if we put a lot of planes together, we get space. So I said, if you have a plane like a sheet of paper, you could fill up a room with sheets of paper. That's kind of the idea, is space is three-dimensional. It's all around us. Collinear points. I said yesterday when you encounter a new word, sometimes it's helpful if you can kind of break it down to its parts. So here we've got co and linear. What's linear mean? In a line. And then what's co mean as a prefix? Together or with, or like a helper, like a co-pilot. So collinear points are points that are working together to make up a line. Okay. Collinear points are points that are all in one line. And in geometry, when we talk about a line, we're talking about a straight line. So we're not taking any curves or any corners, a perfectly straight line. Coplanar has that same division to it. Planar, like a plane. Co, working together with or to make one. So these are points that work together in a plane. An intersection is all of the points that are in everything concerned. So if I have two lines and I intersect them, I get a point where they meet. If I have two planes and I intersect them, they meet in a line. By the way, my art skills, kind of subpar, right? I'm a geometry teacher. I love the math. I love the theory. My art, so you will have drawing problems that you will need to do. Don't worry about being perfect in your art skills because I can't penalize you for that since I can't do it. Some people are gifted that way, some people are not, and I sadly am not. My father is an amazing artist and it did not come down to me. So when those two planes intersect, they make a line. So intersections can be all different kinds of things, but an intersection is what's included in everything. Questions on any of those terms? All right, so we got some true or false questions now. So let me describe for you what's happening in this picture so you can kind of visualize it. It's really a three-dimensional kind of thing, but it's smushed down onto paper. So sometimes it's hard to tell what's really going on. So what you can imagine is that we have like a sheet of paper that's called M. That's our plane. A plane is like a sheet of paper. So we got this sheet of paper called M, and on that paper somebody drew a big X. Okay, so there's that big X on the middle of that paper. And then somebody took a pencil and stabbed it right through the middle of that X. So that line, XOY, is going down through the middle of the paper. Okay? So it's like a piece of paper with an X drawn in it, and then something stabbed right through the middle of that X. So, some questions about it then. Line XY intersects plane M at point O. Is that true or false? That's true. An intersection is where things meet. That line that I said is like a pencil stabbed through the paper is meeting the plane at that point O, right where it's cutting through the paper. Plane M intersects line XY in more than one point. So we just said it intersects at point O. Does it intersect anywhere else? No. It just cuts through at that one point. So this is false. Right, there's all those little dotted lines, so it looks like there's a lot more points in common there, but there's really not. Points T, O, and R are collinear. Now remember, collinear means they can all be connected with one straight line. Can T, O, and R be connected with a straight line? They cannot. X, O, and Y are collinear.
True.
That is true. They are all in a line. R, O, S, and W are coplanar. R, O, S, and W are coplanar.
No. Yes. True.
True. They all exist in plane M. They are all on that flat sheet of paper. R, S, T, and X are coplanar. False. R, S, and T are all in a plane together, but X is not with them, so that is false. R, X, O, and Y are coplanar.
False. False.
Trick question.
True.
It is true. They don't look like it, right? Because there's no plane drawn in there. So what was our big lesson from yesterday? Don't trust our eyes. Don't trust our eyes. Big lesson and big idea for today is just because it's not there doesn't mean it can't be there. So we have to think about, is there anything we could add into this picture that might help us out? They are not all in plane M. That's true. But is there another plane that could contain them all? And the answer to that is yes. I could take another piece of paper and kind of slide it on through there and catch those points. The reason why this problem is different than the last one is because 3 of the points were in a straight line. and then the other one wasn't. In the last problem, R, S, and T were making a triangle. And so there's no way to bend the plane to grab the points of the triangle. But here they were all in one straight line, so then I don't have to bend the plane. So that one is actually true, put there as a trick question to emphasize to you to always look for adding things into the picture. Questions? Yes.
Would it still be that if it was R, T, X, and Y?
R, T, X, and Y would not be true because 3 of them aren't in a straight line. You need 3 of them to be in a straight line for it to work. X, O, Y, and any of the other letters would work. Yeah. Or R, O, S, and X would work because 3 of them are in a straight line, and then I can grab the other one I need. Okay? So R, O, S, and X would work to slide a paper through there. Okay? So if 3 of them are in a line, then we can still slide another paper through and grab a 4th point. Yes or no? Here we're thinking about our descriptions or definitions. Plane doesn't have a definition, but it does have a description. Does a plane have edges? No. When we draw it, it does because otherwise we couldn't tell where it is. But truly in geometry, we say planes are unending. Can a given point be in 2 lines? What would that look like?
Intersection.
An intersection of an X. So we could have an X and there's 1 point in both of those lines. Could it be in 10 lines?
Yes.
What would that look like?
There's a circle.
So we got a star, an asterisk. My husband manages a bike shop, so bikes are a big part of our life. So I start to see like bicycle spokes when I do that. But it's possible to put it in as many lines as we want. Can a given line be in 2 planes? So I already drew a picture of that earlier, where if I have 2 planes intersecting, what they share in common is actually a line. Again, you can kind of think of pieces of paper, and if you cut each of them only halfway through, you can kind of slide them together that way, and that's what we've got going on here is like a model. Could that work for 10 planes?
Possibly.
Sure.
Yeah, it's a lot messier to try, but you could kind of keep on sliding more papers into there. I definitely can't draw it. In this picture, we have kind of like a shoebox. We want to name a 4th point that is in the same plane as the other 3 that are listed. So what point is in the same plane as A, B, and C?
D.
D. We're naming off the top of the box there. A, B, C, and D would give us the top of the box. E, F, H, and G. That's the bottom of the box.
G.
D, C, H, and G. That's the back of the box. Okay, you guys are answering those really quick, so here you go. How about A, E, G?
C.
So I got A, E, G,
C.
C. We're kind of taking like a piece of cardboard and sliding it down the diagonal of that box. Alright. So again, just because it's not there doesn't mean it can't be there. So we can draw another plane into that picture. Questions? Alright, so we've got that same picture and it tells us that we're going to call the top A, B, C, D. Now when we name a plane, you can start with any point you want. You can go around clockwise or counterclockwise, but don't go back and forth. So I could call the top of this box A, B, C, D, going around in a circle. I could call it D, C, B, A, still goes around in a circle. I cannot call it A, B, D, C, because that bounces back and forth. Okay? So when you name a plane, pick a point, it doesn't matter which point, go around. It doesn't matter which way, but don't bounce back and forth. Okay? Alright, so are there any points in line CG besides C and G? So we've got line CG over here. Thinking about what it told us a line is, are there other points there? Yes. They're not named, but a line is completely full of points. So they're not drawn and they're not named, but they're there. So we have a lot of points there. Are there more than 4 points in plane ABCD?
Yes.
Yeah, if a line is full of points, a plane is really full of points. Name the intersection of ABFE. So ABFE is the front, and BCGF, the side. BF. It doesn't matter whether we call it BF or FB, but we do need to use capitals, and we do need to use the line symbol above it. The order of the letters does not matter, but we do need to use capitals, and we do need to use the right symbol. Last one, there are several possible answers. We want to name 2 planes that do not intersect. So who can name them? ABCD does not intersect with which one? FGHE. Top and bottom. Okay, so top and bottom is one option for an answer. Left and right would be another option, or front and back.
Wait, what's the, you know how you put like this, the line over the BF? What do you
Yep.
put over ABCD?
A plane does not need a symbol.
Okay.
A line is the only one that needs a symbol. Tomorrow we'll learn about several other things that do need symbols, but today just a line needs a symbol. Drawings. So like I said, I'm not good at drawing, and so I ask that you just do your best. I will be checking that anything that has a name is labeled. Okay, so that's important, that we label what is to be said. The traditional way to draw a horizontal plane is with its sides as the slanty parts. Okay, we don't just draw it as a straight rectangle. It's slanted through, and when we call it a horizontal one, we make the left and the right side the slanty sides. This plane is supposed to be called N, so I'm going to put an N somewhere in it. And it needs to contain a line called C. Since it contains the line needs to be completely within the plane. It could be right on one of the edges, but it cannot go outside of the plane. It doesn't matter what angle or what direction, but it should be within the plane itself.
When you have arrows on the ends of the line like that, doesn't that mean it continues?
The plane also continues,
Oh, yeah.
so it'll still stay housed within it. Yep. So we do want arrows at the end of our lines, so that is important.
So then it doesn't really matter how you draw it, whether it's
Right. Yep, you can draw it completely horizontal, vertical, at an angle, as long as your arrows are still staying within the plane. So like this would be another okay thing to do, is putting it right on the edge. That would be an okay place for it. But something that is not okay to do is to like make it extend out beyond. Okay? So it needs to be inside or on the edge, but not going outside. Draw a horizontal plane A. So we said in the last one, our horizontal planes have their sides slanty, and we're calling that A. A vertical plane B. For a vertical plane, we do the opposite and make the top and the bottom the slanty parts.
Way too big.
And we're going to intersect them at a line, that diagonal line in there, and we're going to call that CD. You can put the C and the D anywhere on that line. I'll put them at the edges, but you could put them in the middle somewhere. It doesn't really matter as long as they're on that line. Now if we want to get a little bit more proper with our drawings, we can use some dotted portions here to show what would be hidden, and that gives it a little bit more 3D perspective to show that at the top, plane B is kind of hiding that part of plane A, and then underneath plane A is hiding that part of plane B. So that gives a little bit more perspective to it. That's how the book will draw it when they try to show you planes intersecting. Questions? One more? we want to draw point A, not on plane C. It doesn't tell us what kind of a plane, so you can draw any kind of a plane you want. I tend to draw horizontal planes unless I'm otherwise told, but it doesn't matter. You just need some kind of a plane C, and you need a point A that's not inside of it. It doesn't tell you where, so just somewhere not inside of it. Line M goes through point A and intersects through plane C. So I'm going to draw a line that goes through A and down through C, and I did that little dotted out to show that there's some three-dimensionality here, that the plane is kind of hiding the line. And we're told that they intersect at a point named X, and that the line is named M. So when you're finished with your drawing, I would suggest reading back through the problem and making sure that every one of the letters in the problem is present in your picture. Okay? Make sure that everything that had a name gets its name in the picture. Okay. Questions? Okay, your homework is from 1.2, written exercises, again, remember. So this is on page 7 of your book, but it starts at the bottom of page 7. At the top of page 7 is classroom exercises. We actually did a lot of those. If you start doing those, they should feel really familiar. At the bottom of page 7 is the written exercises where you're going to begin doing your homework. It looks like a lot of problems if you look at the numbers and would start listing them out, but like our examples, a lot of them are yes and no, or true and false, or name this quickly kind of thing. So hopefully it shouldn't actually be that heavy of an assignment for you. Okay? And that assignment will be due tomorrow.